Hello, this is Christer Sandahl, again describing my highly useful complex product development model. This clip will show how to organize development to fit your product as well as your preferred methodology. As I have shown in my previous video clips and show here again, this CPDM basic technical schedule is simple but comprehensive. In fact, too simple to be used for complex products. Also note that the symbol letters refers to the activity names. The too simple schedule can be expanded to a flexible and powerful model by making it nested. There will be important connections between the nesting levels. These connections even have been given explanatory expressions. Now imagine to drag the top nesting level apart. Adjust the connections to the new figure and put back the explanatory expressions. Repeat to drag the next nesting level apart. Again, adjust the connections and also put back the explanatory expressions. To drag the sides apart can be repeated to the level desired. Hocus pocus! The nesting level schedule is now illustrated as a V-model. One of the great things with the V-model is that there is no longer any arrows going backwards, which means that the elapsed time is much better visualized. To explain how CPDM uses a V-model, let's look at an example. Let's develop a digital distortion box, giving the guitar sound the heavy metal rock and roll character. The chosen CPDM nesting levels corresponds to 3 anticipated architecture layers. The top level of the V-model is the product environment, which addresses everything outside the distortion box. There are 2 identical product levels, one addressing the target box and one addressing a PC simulator. The software is the bottom nesting level, addressing development of software in 3 increments. All software increments are verified in the PC simulator, and the last increment is also integrated and verified in the target box. So, let's look a bit closer on the 2 legs and the 3 levels of the chosen V-model. The technical development starts with the left leg of the environment top level, which contains capturing of environment requirements, proposals of environment solutions, and designing an architecture of the environment. One environment requirement example and one environment architecture example is shown in the figure. Now, let's move over to the right leg of the environment level. Note that we now approach the end of the technical development. Here the integration of the box into the environment takes place to prepare it for field verification. The picture shows one integration activity and one test case. Now, let's move down to the left leg of the target box level. Here is now capture requirements for the box. Solution proposals are made and an architecture is defined for the target distortion box. In the figure there is one target box requirement shown together with an architecture for the target box. Now, let's move over to the right leg of the target distortion box nesting level. We are now at the end of the distortion box development. Here the target distortion box is integrated by assembling all electronics and loading the software to a permanent memory. The figure shows integration activities and the verification of the box distortion when distortion is not activated. Now, let's move down again to the left leg of the PC Simulator nesting level. At this level, the requirements for the PC Simulator are captured, solution proposals are made, and PC architectures are described. In the figure is shown an example of a requirement, and there is an architecture example of the sound path of a PC. The PC Simulator is then integrated by loading developed software to its working memory, and in the figure also an example of a test case is shown, describing how the PC Simulator can be verified. Moving along the PC Simulator nesting level shows how the PC can be used to integrate and verify each increment of the developed software. Now, let's move down to the bottom nesting level, showing how the Distortion Box software is developed incrementally. First, in this level, the software requirements are captured, alternative solutions are evaluated, and an architecture is drawn. See some examples in the figure. The software is compiled, linked, and executed in the development debugger. The figure shows integration and debugging examples. Moving along the software nesting level shows that one after the other increment is developed and debugged. Any incremental development methodology of choice can be applied, for example Scrum. Note that for each increment, the software can be realistically verified by the PC Simulator one nesting level up. This was a CPDM example, how to build a comprehensive and efficient complex development model from V-model building blocks. To conclude, it is important in CPDM to gradually align the process schedules with the emerging architecture in the way the figure indicates. Also note that CPDM contains efficient overall models, totally consistent with all needed nitty-gritty details. You never get lost when applying CPDM. CPDM is available from most internet bookstores as a paperback book or as a downloadable e-book. Thanks for watching. See you in my next video clip.